So today we have a special session, I would say, because Jordi 2 or 3 weeks ago talked about how to install VC-Minar with Dpdk, but there was something that is not so trivial for all users or people who are not familiar with the subject, is to basically install Dpdk, first of all. And this is not so trivial, simply because it really depends on the platform, your I would say your CPU configuration. You can do a lot of things in order to optimize the platform, but today we will just focus on installing Dpdk, and if we have a bit of time, we'll see that later. Maybe Jordi will complete this Dpdk installation by simply activating VC-Minar. So we can check how we can spin a VC-Minar on a Dpdk server, but we'll see that if we have time and if it works, because usually it's not rocket science. It's not something really hard to achieve, but the thing is that this is a case-by-case hardware issue, and the good news is that if I presume that Carmen will also demonstrate how to install Fiscal traffic generator, because we have played a bit with her this morning and yesterday. So everything should be ready, and I guess that this is something that Xavier and maybe Christina and Ital would be interested, because with Fiscal what you can do is to generate traffic, and based on different type of flows, which can be great. For example, if you want to start doing simulation with multiple flows and expect that these flows are, I would say, steered within the backbone according to your policy. So that being said, Xavier mentioned he's interested, so that is great. Great to know. And I hope that this will help you, Xavier, so that you can provide the knowledge to your colleagues in your white box task that are elaborating, I would say, the test suite for basic research and education use case. So that being said, Carmen, the floor is yours. What you can do is to start your screen and just show off how with the Dpdk is installed.
Okay. So, well, this is here we have Ubuntu 20.04 server installed on the target. So, well, here I have my cheat sheet. So first we need to update and upgrade the system, and then simply install the Dpdk library and Dpdk dev library. Here we have this is the card that the server that we have here connected is a 10 gigabit Ethernet, and so here is where we can check which is the target that we have connected, because after that we need to know what is the driver that this target has got in order to know how to process it. So then we need to create this path. Basically, we need to change to opt folder and create the T-Rex. And after that, with a wget command, or also in the website, we can download the latest version of T-Rex. Okay, so and after that, we just need to enter this file. In this target, we have 2 sockets with 8 cores per socket with 2 threads. So in total, we have 32 cores available, because Dpdk is based for the data plane, but you can dedicate all the sources that you have. For example, here we have these 32 cores. We can split and dedicate the traffic per link. So using huge page, which is a functionality that enables us to create this, to split this. Later we will divide these resources into different links. So we have this, and also we have available a total of 256 giga of memory in the target. So after installing this Fiscal T-Rex, which is just to download for the internet this version and then enter it, we need to enable the IOMM module on the switch. So we need to access to the group from here, and at the beginning, here in this line, the groups, the line Linux default, we are only going to have this, maybe ubiquity, but we are going to add this line. So here with huge page, we are taking 16 pieces of 1 gigabit, and also 2048 of 2 megabytes. We are enabling the IOMMU module. So then we need to escape, and after that we need to update the group that is on the switch and reboot it. It will take a few minutes, but no problem. So after that, we need to check that the module is enabled. So if we use a DMSH to grep, we will see that this is the command that we write it. So it's enabled, and here, this is the important message. Is enabled. And then we have everything enabled and working, but we need to set up the ports by using this Dpdk setup ports. Okay, so the no.
If you do Dpdk, Dpdk def and
Minus S is the status, no?
Exactly.
So here we have on the other network these two interfaces. In this case, well, I have a diagram of the network, but well, it doesn't matter because here there are the two links, but now this one there are not binded to the kernel. So here these four interfaces are bound to the kernel, but this one's not. This is a small problem because at the beginning I binded this to the kernel and then to the BFIO, and now I'm trying to unbind, and now I'm not able to bind it again. But this is an important command because I'm using Ubuntu, and at the beginning when I try to bind, that always gives me a problem, saying that it's not. It cannot bind, but it was something related. It depends on the target sometimes, but setting up with this command, the unsafe no IOM module, it works to me.
If you try to bind again, it doesn't work.
No, no.
Directly with -b, so copying the dpdk def bind -b.
Yes, dpdk -b. It doesn't matter if I try to bind to the kernel or not. It's not working. 0.0. It says that it cannot bind. And it's very strange because I have it already bind.
And what do you have in dmesk?
For example, DMS. What?
Enter, just enter. You see the end.
It's broken.
Devices currently used. If I remember correctly, you need to, sorry, because there is a train passing by. I don't know if you hear it. I'm at home today. I think you needed to remove every single configuration from the card. Maybe Frederic can remind that, but I think there is, if you do an IP space ADDR, and do you have it enabled, the card, or not? Do you see them there right now?
What? Can you repeat, please?
So if you add an if config, because I think if I remember correctly, there is a, let me check. I think you need to there was a cleaning.
Okay, so Carmen, can you open the Tmux window? Attach. Yes. Yes, exactly. So first of all, we need to what we need to do we need to stop the binding. So we need to stop the console. So you kill the console, and I can do it if you want. So Control C, and then you need to type exit. Okay.
Yeah, basically the card was in use, right?
Yes, exactly. So that's why it did not work. So now you can unbind it, of course.
But you wanted to do the BFI or PCI, right? Instead of that, or not? You are mute, Carmen, you are mute, sorry.
I don't know why this one is not working now. The last interface. But well, anyway, now before
Carmen,
that,
from your notes on the right, on the left, sorry, you wanted to do the BFI or PCI, right? Instead of that one, or that driver?
yes, because now I want to bind it to the kernel, and then I
Okay.
will unbind and pass it to the
Okay.
BFIO. Sí.
Okay.
Cannot bind.
Did you unbind that one first? Yes, right?
Try to unbind first. It's not
No, it's
right.
not.
Okay,
It's
so now try to
not-
bind again. Let's see how it goes.
So dmesg, and let's check if there is something there. No, that's for 2, and for 5 we don't see anything. It says 6,000. Do you know if 6009 is the PID, Frederic? In the
one,
comment
sorry?
from device is currently in use, task Dpdk diff bind 6009. So we need to check who is using that device right now.
Yes. So do you
With
have
LSO?
something? LSOF?
Yeah.
OF? No.
Not just all together. That's it. And now we have to check how was this? I don't remember.
You have LSOS track something, but it's
grep,
not.
just grab it and look for T-Rex maybe.
No.
T-Rex is in the middle of the window. At if I don't know if it's
Yes, but it's a directory. It's not a. Okay, so you in this case, Carmen, what I propose, maybe this is a misbehavior when you bind and unbind. So what we can do is to reboot the box if you want to reboot the server free. So while she's doing the reboot,
okay.
Yeah, while she's doing the reboot, Carmen is doing the reboot. Of course, so the first thing is to install Dpdk. So the first thing is to make sure that the system is already updated. So it's apt-get update, apt-get upgrade. Then you install Dpdk. As we are on Ubuntu, you are using apt install Dpdk and Dpdk dev if you want to compile stuff with Dpdk. Second thing is to check the CPU capability. With LS-PCI, and then you could see that this is a 2 socket, so it has 2 silicons, and each silicon had 8 core in it. As we have a high Intel hyperthreading, so we have the equivalent of 16 processes that can run in parallel per core. As we have 2 sockets, it gives us 32 I would say vCPU. So this is the idea of that. Next thing, once you have installed Dpdk, is to make sure that you have installed the huge page, because Dpdk need to have a dedicated space in terms of memory in order to do packet manipulation and stuff. And in this case, we have allocated huge page during a server when the server reboots. So we don't have to care about huge page activation because it's activated at boot time in the kernel. And Carmen explained us to do that via the grub, the /etc default grub. And then you have to make sure that you launch update grub in order to make this effective. If you don't do update grub, you can do all the things you want in the etc default grub file. It won't be taken into account. In that case, we are using Ubuntu 20.04, and then what's happening is that we have added new parameters that is called the huge page size 1 gig, and we have allocated 16 page of pages that have 1 gig. So basically, it's 16 gig. With that in mind, we have also huge page that has size that have smaller size, and I think it's 2 meg. So 2048 is 2 meg, and then we have we have 2 meg of page, 2 meg of size, and then we have allocated 2048. So what does it means? It means that we need to make sure that all the servers can cope with that. If you allocate an amount of huge page that is too bigger than the VC's physical memory is available, I have done this already because I'm not super good at the system administration. The good thing is that you have a very beautiful kernel panic at the console page, at the console during the consoles. I can guarantee you that this is what happened to me, and I had to log into the console and then go edit the grub entry and lower the number of page allocated. So pay attention to that. The good news with Carmen server is that it is I mean, for me, it is a very good and big server that has 256 gig of RAM, which is for me something big. Maybe not for Jordi because he has a lot of big servers also in University of Murcia, but it's quite big. So basically, the number she put is okay. I even think that we should not go over 256, even if we are allocating 32 huge page for 1 gig and 4096 number of huge page with that has size 2 meg. So the next thing is that all this huge page stuff is great, but this has to be allocated via a specific mechanism that is called IOMMU. IOMMU stands for input, output, memory allocation, or memory map unit, or something like that. So basically, you have to, the thing that is important you have to know is that IOMMU is here to ventilate the memory, to allocate the memory that has been allocated in huge page to Dpdk. So this is why we need this. We need this. And this is done via a driver for the Intel case, for Intel card case. It is done via a driver called VFIO PCI. This explains all the magic command that Carmen is providing here in this. The next thing is that as we have a very Ubuntu 20.04, you have to know that Ubuntu 20.04 has VFIO directly built into the stock kernel. So what does it mean in reality? Practically is that when you do a ls mod, it won't appear. So for example, Carmen, can you do a ls mod on the screen? Pipe grep VFIO. No, sorry, grep VFIO. You will see that there is nothing. This doesn't mean that it is not activated. It simply means that it is built in inside the kernel when the kernel and you don't see it. In other distribution like Fedora or Debian, Seed, and Stable, VFIO is built as an external module. So when you do a ls mod, you will be able to see this module binding. But this doesn't mean, in this case, it doesn't mean that VFIO is not working. So that being said, what is important in the magic command sudo echo yes is that actually it seems that Ubuntu disable unsafe IO MMU mode. So we have to put a yes on this. So of course, this has to be done after each reboot of the machine because this is not persistent. I recall that if you want to make this persistent, you have to modify the file. I'm not sure. Correct me if I'm wrong, Jordi. You have to modify the file called /etc/ctl.conf.
Exactly.
And then magically, it will reboot with the config. Can you check the cctl file here? vi/ or cat, whatever, cat. Yeah, etc cctl sys sys tab. No. Remove the slash tab. Sys tab. No tab. Yes, exactly. cctl.conf. Bravo, Carmen. So here, this is the system that needs to be tweaked during boot time. So you see that there is a yes, so maybe it is 1. It can be, for example, I'm not sure what is the parameter for VFIO, but it can be VFIO dot parameters dot enable in safe mode equal 1 or something like that, or 0. I'm not sure, but we have discovered this with Carmen just this morning. So when this has been done, we'll see that later, Carmen, don't worry. Now we can exit the file. And now that you have enabled huge page, IOMMU, technically, Dpdk is able to run. So what you can do is first to launch a command called Dpdk. Dpdk. Can you type Dpdk dev bind -s? Yes. So this is the status, and you see that the kernel is see a bunch of interface port. Sorry. Network interface, sorry. So if you look at it, we see on the left, you have the PCI address on the bus, okay? And you have the name of the interface and also the driver that is enabled on the kernel. And basically, you see that VFIO is available, and this is built in the kernel. So why it is important? So if you type EIPA, IP space A, Carmen, you will see that these interfaces are visible here. For example, ENP5 S0F0 is PCIe 5 0 0 or 0 0 or ENP5 S01 is PCIe 05 001 on the above, on the Dpdk above output. Okay. ENS2 is 0200. So that being said, the good news is that Carmen has checked for us that these cards are Dpdk compatible, and the driver is that is IXGB, and this is also accessible via VFIO PCI. So now can you do a dpkg kg space -l pipe grep GB GBE GB, yes, GBE, enter. So what you see, these are Dpdk package. You see the IXGBE 20.0, the last one. You see the package. This is the poll mode driver of Dpdk. So it is compatible. If you have a Mellanox card, can you do the same command, Carmen? But you replace GB by MLX. No, MLX. No, not MLX. Yes. You see, you have Mellanox Xconnect 4 supported and Xconnect 5 supported. So if for any reason you have Xconnect 5 or 4, you know that it is supported. However, you will see that you will see that VFIO is not used by Mellanox because the Mellanox driver can be seen directly by both Dpdk and Linux kernel at the same time. So you don't need VFIO. I have done this already on a different server with a 100 gig port, MLX5, and it works. And the strange thing is that Dpdk can see all the interface in Linux and also the interface on Dpdk. Jordi, you wanted to say something?
I wanted to say that basically on the first try we had with the Mellanox card, we had to also update the firmware of the card and so on to be able to work well with the Dpdk, if you remember.
Exactly. Yes. So for now, Carmen, this is the easiest path we decided. But it can be even worse and even more difficult. It's that your server can run a VM and you want the VM with an interface that is Dpdk enabled. And then this is where the headache is appearing. And this is where this driver and PMD driver configuration can be a little bit more tedious. But in our case, we are not using VM. We have plain server because we are in CERN.
Because we are rich. Say it.
Well, I won't say that CERN is rich. I would say that CERN is a very good place where you can find a lot of huge server. So that being said, I guess that we have almost everything in hand, and we have explained what Carmen has done. Now let's see what's going on with this server 3, because I think she was trying to set up this one.
Yes. Now, what I want to say, okay, is so now the status is that all the interfaces are being binded to the kernel, but now we want to bind it to the VF-IO PCI. So yes, we need to unbind it. 0, 2, 0, because we are taking the ENS interface and the EMP-S5 F1 interface. So the PCI address are the 2 and the 5.1.
So Carmen, after this operation, can you launch again IP space A? So if you look at it, the now ENS2 and ENP5 S0 F1 interface have disappeared. This is important to understand that this means that they are taken into account now and managed by Dpdk. And now what you can do, Carmen, is to launch the Dpdk, yes, exactly this one. You see that now now the dev status says that they are not managed by any process, nor the kernel, nor Dpdk. It's over network device. You see that the above, the cards that are remaining, corresponds to the IPA output above. Okay, you have 1, 5, and 8, 80, 81 that are appearing above. They are called ENO, ENO1, ENO2. So now I think that you want to bind it.
Now I want to bind it to VF-IO PCI. And the same for 5.1.
And it's working.
Yes. And now there are bind to the Dpdk compatible drivers.
Exactly. So now that we have this operation, we can write our program, our Dpdk program in C code, in C language, in order to use the stuff. But this is what Trex has already done for us. Basically, Cisco Trex is an open source traffic generator that is using under the hood SCAPI engine to forge packets. And then it uses Dpdk power to reach traffic rate that are only accessible by Dpdk without a low amount of CPU. So maybe you will want to show us. So now everything is ready, I think.
Mm.
So now, Carmen, you can, for example, configure Trex for the first time. I'm not sure if it will work. Will it work? This is the.
Okay. So
when you launch Trex for the first time, you need a configuration file. And this is what normally Carmen will. So you can edit this file manually, but normally they have a tool, Trex proposes tools that is doing that.
yes, is the Dpdk setup ports, no?
Yes. So it says that, do you want to create an IP-based configuration or a MAC configuration? As we tested IP-based configuration, so yes, it's no. And then Dpdk, the tools is saying that there is two Dpdk interface, that is 0 and 2. And when you create the configuration file for Cisco Trex assume that you have ports that are working in pair, usually a TX, a port that is TX, and another one that is RX. But you can have another one that is, but it's not that important. You need to have two interfaces, because usually in the tester part terminology, you have a Cisco Trex that is connected to something that is called a DUT. DUT stands for device under test. Okay, so Carmen, of course, has chosen ID 0 and ID 2 because they have VFIO PCI and they are controlled by Dpdk.
Here and here.
Exactly. She can put now enter. Let's put let's not change the IP address. We'll see that later. Preview. And then Dpdk has generated a basic card describing also your CPU, and it uses one socket, which is socket 0 with a different thread. Okay. So now what we will do is that what we can do, Carmen, is that we can configure what we can do is to go on server 2, that we configure this morning and do the test, because it will be the same. Or you want to activate it also on this interface?
Whatever you want. In the morning, we use the server 2, not the server 3.
Yes, but do you want to activate it right now?
Yes, if you want.
So we can activate it, but so in that case, you need to go on the P4 switch, because if I recall correctly, this is connected to the P4 switch.
Yes. Well, I already created the IP before root.
Oh, so can we go to the switch?
Yes.
So Xavier, if you spot it, now we are connecting the tester to the P4 switch. And the good news is that Carmen did almost everything already. So what are the interface?
In the morning we use the network 17 and 48, but
Yes.
now I created this one. They are very similar.
26, super. Great.
And 58.
Okay, so it's free 3331 and 3332. So it means that what is the interface connected? It's I guess it's SDN 50 and SDN 110. Or maybe you change it as well.
In this case, we are in server 3, so it's the SDN 50 and SDN 111.
Okay, so can you do show run? Yeah, show run SDN 111. So, and 50.
These two.
Okay, so now for the audience, we can show them the real good diagram.
Ah.
Sorry. And if you see server 3 is on the bottom right.
Yep, here.
And this is SDN 50 and SDN 111. Okay. So you change the number also.
Yes.
Very good.
Just here in the diagram.
Sure. Sure, that is great. So now that what you have to do is that let's challenge a little bit Xavier. Xavier, are you listening?
Yes, but I am a little bit lost.
So here we have connected Dpdk and Carmen has showed us the IP. Can you show us the IP again? It's 4442 and 3331. And she has also configured the static route.
So here we are on the Dpdk
P4
server.
switch. No, we are on the P4 switch.
Okay.
Now, Carmen, can you show us the route?
Here.
Yes, this route. Very good. So you see that the next step is 3331. So what do we have to do now in order to enable this interconnectivity between the two, Xavier? If you maybe you did not saw the server, the Cisco Trax configuration.
It's on the left, on the right. You can show
Yes.
me.
So basically, you have to configure now Cisco Trax so that you have IP connectivity. So now this is what Carmen will do.
Yes. Okay.
So now we need to edit.
Yes, exactly. So please go ahead. So is it clear from your side, Xavier?
No, I see that it is exactly the same address. So I am.
No, it's not the same.
It's
now it's the gateway.
Oh, okay.
So 3331 is the IP address of the Cisco Trax port and the first Cisco Trax port. And the 4441 is the other IP address of the Cisco Trax port. And the default gateway 3332 is the P4 switch on the right, on the left.
Okay. In the same box, to get from one card to the other one, you have to go through the P4 box, basically.
Exactly.
But you are going out from one machine and getting back to the same machine.
Yes. So, so if you, and so Jordi, I think you understand this. What is the DUT here?
Sorry,
the DUT, the device under test.
The P4 switch.
Exactly. So now this is configured. Very good. So maybe you want to launch your T-Rex, or maybe if you are not comfortable, you can.
Sorry, Frederic, I have a question, but it is basically T-Rex related, because we need to have two cards for the T-Rex, right? One for going out and one to going back. So why do you need two servers? I mean, is there a possibility to send from one server and receive from another one?
No, we even have 3 servers simply because CERN wants to have the possibility to demonstrate that we can send different flows from different ports from different servers.
Okay.
That's it.
Okay. No, I was thinking in just one test with the 2 servers.
Exactly. In one test, we don't need.
Okay.
And it's even very good question. Let me tell you one thing. If, for example, you have a server that has only 1 card, but Cisco Trex configuration forces you to have 2 cards. So you put any random number, you put 0 and 1 or 2 or 666, whatever, and then you change the configuration. And instead of putting, for example, 05001, you put dummy, D-U-M-M-Y. You put dummy. It's a dummy interface and it will work. And then Cisco Trex will assume that you have 1 real interface and 1 dummy port. And you will just be able to send traffic from there and receive traffic from there. Okay. So Carmen,
I buy that one.
Carmen, the floor is yours.
Okay, so under the fold STL, there are a lot of examples for C to test. Here,
just a side note. STL means stateless, and this is the opposite of stateful. When you want to do stateful tests, sometimes you can emulate stateful tests with Cisco Trex. Stateful is like, for example, when you want to maintain states between flows. And for example, when you want to, if you activate NAT functionality, you create a rule and that has a specific state. And then you need to do this type of stateful test. Same for the firewall. Okay. In our case, we are using stateless test. And stateless test is basically I'm sending traffic and I will let the network deal with that. I don't have to maintain state between the flows. Okay.
Can you show me the configuration of the P4 switch, please? Sorry for that, but I don't understand what is exactly the configuration of the port that is just in front of the T-Rex 331.
See, they are on the left.
It is which SDD 111?
Yeah, SDN.
Okay. And after that, the traffic, when it goes there, where it goes when after it arrives there?
Can you go on the switch, Carmen, please, and do a show run pipe include you yes, space, and now you put the IPv4. You see there is 2 routes, there is 4 routes. You have IPv4 route. It says that packet destination 26 goes to 3331 and packet destination 5800 goes to 4441.
Yes, okay.
Okay, so this is the configuration of the P4 switch for the T-Rex. That's it. So what that it means? It means that if we are receiving traffic to destination 5800, we will send it to 4441, and the next stop of 4441 is SDN 50. Is it clear from you, from your side?
Yes, but my understanding is from the comment of Jordi, is that the traffic sent by the T-Rex is going through the P4.
Yes.
Okay, so
it will.
Okay, so you will send the traffic to which interface, to which address?
So this is written on Carmen's test here. It is called, the task is called UDP 1 packet. We send 1 packet that is UDP. The source is 58 and it's going to 26. So here we do a basic test here.
Oh, okay. Oh,
okay.
I see. So,
is it okay?
so you you will send the packet to the interface.
Destination 26.
Yes, the destination.
Maybe you can. I mean, maybe you can
No,
show
no,
the
yeah, I
route
understand.
for the server, so that because basically you need to have the route there to send it to the before switch, right? As the default router for that network.
But in T-Rex, you don't have, there is no routing. In T-Rex, you have port 0, port 1. That's it.
So you send it directly, and since the packet is directed to 26001, the P4 switch will take a look at the routes.
Exactly.
Come in through SDN 111, I guess, or 50.
Yes.
I don't know, one of those.
Yes.
And since the destination is 26001, it will send it to 3331, which is on the other card, let's say on the other SDN
Port.
50 or whatever,
Yes.
and it will come back through the other interface of the T-Rex. That's it.
Exactly. So now, Carmen, do you want to use Tmex for that? So we can have both in hand. I think you need to create one.
No.
Minus S.
Yes.
Yeah, well done.
So now we need to launch the Tisco T-Rex server.
So we launch T-Rex, yes. It can be more complicated if you have different cards. Assume that it's not the universal command. So we have to wait a little bit because it's initializing a lot of things.
Yes, and in the other window, we're going to launch the T-Rex console.
So on the left, you have the server, and on the right, you have the console. The console can be run anywhere. But we have a port destination is unresolved. Here, can you see the?
Yes.
So I'm not sure. What does it mean? Maybe port 0. Do we have the right config? Yes, I think. I mean, is it the right? Is it the right interface in front of the? Yeah. So let's try to send traffic. So we are launching the traffic that is in STL folder that is called UDP one packet simple, and I think it's 58 or 58 underscore 26. And we'll put, for example, 1 Gbps, 1 gig.
Through port 0.
Yes. So we have something that is indeed not working here simply because there is some mismatch configuration maybe on the track side. So we need to check why port destination is unresolved. I hope it is not a physical issue, for example. So can you go? No, exit, yes, if you want, you can exit. And try to edit the Trex configuration file. For me, this looks.
So where is the port 0 and port 1? It's just
the first is 0, and the second is port 1.
It's implicit, okay.
It's implicit, yes. Are we? Carmen, are we sure that part 0 is connected to 3331?
But it's complaining about the MAC, right?
Yeah, but this is usually the case when the default gateway is wrong.
The default gateway is 3332,
It should be 2, yes. But
which is the P4 switch.
yes, but this is my
Here.
question. Are we on the same? Are we on the right interface? You see what I mean? Maybe 3331 is below and 4441 is above. I don't know.
Yeah, but 3331 should be implemented on the server.
Yes,
On
it
the
is.
interface. Okay, perfect.
It is.
I ask some question because to be sure that I understand.
Sure.
Okay, do you mean that this 4 and the other 3?
Maybe.
Should I stop the?
No,
the
you have
server?
to restart the
No?
server.
Okay.
You have to restart the
Yeah.
server. And you have also to, if you want to restart the. Can you go on the right now? Yes, it's okay.
That
You
was the
have
problem.
swapped. You have flipped the port. Okay, so now try your test. Maybe you want to send another type of traffic. It should be 2650 if you want in your mind. Maybe I'm not sure. What do you think, Carmen? So we send it on port 0 or port 1?
Port 1.
Okay, so let's go ahead. So now success. You see the traffic is sent and received. So we are sending 1 gig on port 1. And if you look at the P4 switch.
Oh, no, it's on the 24.
No, you can go to the P4 switch. Oh, yes, you can go to BF shell also, yes.
Exactly.
Yes. Carmen, you want to show us BF shell? UCLI, PM, show. You see here, we have ingress traffic and egress traffic. So what you can do is to port stat clear. You can do, for example, port stat stats minus clear, enter. 5, no, you're right. 5/0 and 111. 11/1. Wonderful. So you see that we are receiving traffic on port 1 so which is 111, and we are egress. No, sorry. Well, yes, we are egressing traffic on port 50, which is what we want. Okay. From the P4 switch point of view. So now let's go on the left. You can exit if you want. Exit here. You are not forced to go to BF shell. Huh? Okay, BF shell is just for your information. Now we can go on the P4 switch itself.
But the BF shell says that Eric's traffic is on 11. Receiving traffic.
Is 11, yes.
So it's receiving on 11.
From the P4 switch, yes. Cisco Trex is sending on 11.11. Okay, so perfect. The P4 switch is receiving.
Yeah, that's so 11.1. So in each of the
sorry, 11.1.
Yeah, sorry. No, please, Frederick, go on.
Oh, sorry. So now, Joe, you are on the P4 switch. Now you can do show interface summary. Oh no, sorry. Watch. Can you do watch interface? No. Remove the show. Watch interface summary. No, summary. Enter. So there are a lot of things ongoing. So sorry. Control exit. Control X or Control C. You remember exactly the watch? Show interface traffic. Watch interface traffic. Okay, so it's better. So you see here, FreeRtr is seeing traffic received and is sending traffic to SDN 50. Okay. Does it make sense for you? So now, Carmen, what we can do is go on the right and stop the traffic.
Okay. How do you read the traffic and the...
No, here it's the byte received.
Because there is 0 plus.
Yes, because 0 is software switch and plus is hardware switch received by P4. So you have software. So sometimes you have traffic that is pointed to the CPU. This is the first 0. The plus is hardware traffic, which is switched by the P4 switch.
Okay.
And if you don't have any P4 switch, it's Dpdk. Okay. So now, can you relaunch the command? But now you are using, you can do, for example, you put here 100%. You can put % in port P1, enter. You will see that here it will try to fill up the pipe, and it's 7 gig. So you might say why it is 7 gig and not 10 gig. And I presume this is because we are sending very, very small packet, and there are overhead on each packet, which basically is the maximum that we don't. This is something that you don't see actually. So this is actually 10 gig. But if you, for example, want to send jumbo frame or bigger packets, you will reach easily 10 gig.
There are already some information directly from Intel that has the graph about the packet size and the number of packets per second, and how if you have a low packet size, then you cannot reach the throughput, but just 0.5% of it. For instance, with 64 bytes, if I'm not wrong, it was 50% of the throughput of the card. But of course, the number of packets per second is really high because you get more packets per second. So it depends on
exactly. If you look at the, so Carmen, you can stop, but here you can see that you can easily reach 7 gig. But trust me, with Mellanox 100 gig network card, I managed to send 100 gig traffic with a different size. But of course, it was not small packet size. What you can show here is that your Trex server is has been stopped, I think. And now what you can do is to VI your script. You show the script.
Can you send some traffic that is a mix of different?
Exactly. So we can. This is what Carmen can show you. You can show
like you have a iMix reference, you know. Internet mix.
Yes. You can put the item. Okay, just via STL, via CDSTL, and VI tab. You will see the whole list of packets. Tab, UDP, for example. Yes, tab. Just press tab. Yes. Oh yes, via this way. Sorry. So here we are sending one stream. We are sending one stream that is source 26, destination 48. But you see that the packet size is not specified actually. Maybe it uses the default one.
And so here you send simply a packet.
Yes.
An Ethernet packet, an
yes.
IP packet. Can you make some mixed of packets, for instance, MPLS and things like this?
Yes. You can forge anything you want. So you can exit. But here we are just showing basic test.
Yeah,
You can-
no, of course, of course.
You can exit, Carmen. Maybe you already exit. I could not see it. Sorry, because my window is too small. And then you see you have multiple streams. For example, what you can do is to look at UDP free packet. No, not this one. Can you look at UDP 1518B no CRC? No, no, no. This is a pickup file. Multi-stream, I think, Carmen. UDP one packet multi-stream.
Sorry, can you repeat?
Yes, yes. Multi-stream.
Multi dash stream.
Multi-stream. This one.
Yes. So you see that you have a function called create stream. So you create so you create multiple stream, and then you give them different packet size and different source ID and stuff.
Okay, no, but it was just a question. I think we don't need to
No.
to
You
enter
can-
into the details.
You can
I just
exit
want
if
to
you
know
want.
if you say yes, it's okay for me. It's just
No, but I just wanted to show you that this is possible, but you have to code this.
Yeah,
So
of
with your team, you will have to create this iMix test that is representative. You can exit if you want, Carmen. I want to show you a last thing.
may I ask also a question about hardware?
Just to finish with what the question you ask. You have a test called UDP one packet MPLS. Can you see it? Where is UDP one packet MPLS? So this is a packet MPLS packet with label 17, COS 1, TTL, the MPLS TTL to set to 250, and we see that it is a MPLS that has two stacks, a stack of two here. Does it answer your question?
Perfectly.
So you are free to do a lot of things, huh? Okay?
Yeah.
So
That's
now
nice.
you can exit, Carmen.
Frederic,
yes.
I don't know if you did, probably yes, test the cap2 YAML config from the T-Rex, so that basically you can define what you want in a YAML and it will generate the packets for you.
It's even better, Jordi. You have a lot of open source tools that have a UI, and you check everything you want. You type the field, you type on, you click on the button, and then you generate the stuff in Python. This is called Trex GUI or something like that. I will be honest with you. I showed you the basic part. If you want to create multiple tests, you can do it using this script as example.
And if you, for instance, want to create, for instance, if you want to enable, for instance, if you create a lot of different LSP, you can create it with another free router that is connected to you. But how you can send the traffic corresponding to this LSP? I don't know if I was clear.
No, I don't understand the question, sorry.
So, for instance, if you want to test this machine in his own contest, so for instance, you have 100 LSP that you create.
Yes.
So to create it and to test it on the DUT, you will use free routers to be connected to the machine.
Yes.
And you create your RSVP
yes.
easily.
Yeah.
And after you would like to use T-Rex to send traffic.
Yes.
And you will not be in the same port. So maybe, okay, I will try to see if it's possible. Okay.
Well, basically, VC-Minar will program when VC-Minar will enable a RSVP tunnel. This will be programmed in the NPLS table, and then it's up to you to map this label in your traffic test.
Yes,
Okay.
but if you want, you have to. The tunnel is arriving on a specific internet interface, which is not the interface of the T-Rex.
No, you can no. For example, if you are testing an intermediate node, you just don't care. You have just to map to check your T-Rex will send the traffic, and then a free router will just swap the packet. So you send a traffic with a specific ingress label, and then free router will be able to swap it based on the RSVP on the RSVP computed label.
Okay. I see. Okay, you use the duty, you use the configuration of the duty.
Yeah.
Okay. And my second question is about, can we combine two interfaces in order to have, for instance, 20 gig or 30 gig or 40 gig as a port 0 for the T-Rex?
Simply put, I don't know.
Okay.
I don't know. Maybe you have the possibility to do bundle, but I will I will be honest with you. The single problem I have actually it's only on my case. It's already my problem because I don't have access to servers. Powerful. I'm not that. I have my home PC that has 1 gig if you want, but I can't do this. I don't know. This is a good question, but as I don't have a lot of server with a lot of network, I don't know how to do bundle stuff. The only thing I know is that with FreeRtr we can do bundle and bundle things, and also with Linux kernel. This is what I did already many times, but with Trex I'm not sure. I think you can do what you can do in Cisco Trex. You don't need the bundle. You just need to know the port, and and you simply load balance. You simply load balance different stream, and it's up to free router after that to receive packet and do the hash computation and do the egress forwarding based on the result. But I'm not sure.
I would say, I mean, if you want to test something like LACP or something like that, it would be really hard because you need to implement that on the SCAPI somehow. I mean, the protocol itself. If you just want to feed two cards, then you just need to launch, let's say, two processes, and that's it, right? One sending on port 0 and one sending on port 3.
Yes, exactly. Yes, exactly. Or you can spin one process that can send two streams in different ports. But this is, I would say now this is the art of creating tests, and this is where Carmen will help us because she will become our test guru here because she has a very strong idea in mind, and I'm pretty sure now that as she has everything in hand and in brain, she can do a lot of interesting tests. One very good important thing is that she has already also a lot of servers compared to us. Or at least she has access to a lot of servers. So Xavier, does it clarify your hungry will to understand how Cisco Trex is installed with Dpdk?
Yeah, thank you very much for this. Thank you, Carmen. Thank you, Frédéric. It was very, very useful for me because
so you have to thank Carmen for that. Christina,
I have to say that I started this morning.
she's a very good learner. Christina, any question from your part?
Teacher.
No, not.
No. Are you here?
Yes, we can hear you.
Yeah. Okay. No, it was very good. Thank you for the demo, Carmen. I think it seems to be a very nice tool. I was commenting on the chat that we were exploring PactGen Dpdk. That's another traffic generator. And in that ONDM paper, we used that PactGen Dpdk. And the good thing about this demo that you showed today is that you combine the high performance with the flexibility of this KP. So I think it's very nice tool, and I think we should explore that too.
Yes, thank you, Christina. Yes, because packagent is great, but very limited. With Cisco Tracks, you can really do a lot of scenario. For example, I'm not a Cisco Tracks expert. It just happened that I know a little bit about it. But what I did, for example, for the Polka demo and also for the traffic engineering demo I did 3 weeks ago, is that I sent traffic, but with different flow label. In IPv4, it's not flow label, it is called IPv4 identifier. So I had to set this identifier, and then the flows was different, and then it was processed by the P4 switch differently, and this is how I did. And you will see that it's pretty simple. I can show you, you can find a lot of things in the resources in the web and stuff. And my guess maybe in the long run is to create a very representative test and show this during the one, for example, during next LHC1 meeting and see how you progress and stuff. I think it will be great with that. And Christina, what we can do also is to send different traffic with and then you can also simulate, I think, you can find a way to simulate different route ID because, and then the network will be able to switch it at will based on that. So you can test this. And the good thing is that Trex is not, the good thing is that Trex is not only working with Dpdk, it can work in software switch. So you can have a virtualized lab with a software Trex, do everything, and it will work at software switch based. And when you will reach a big box with 100 gig port and very high throughput, you can redo the test, but of course with more greater bandwidth.
So you mean you don't, because my understanding is that the T-Rex need to attach the ports, and he thinks he supposed that there was Dpdk.
No. For example, I think you can create a VETH interface, which are virtual interface, and then you attach Cisco Trex on VETH, and on the other end you have a virtual lab.
Okay, so we can start with the virtual lab directly on our machine. Okay, perfect.
Yes, exactly. Of course, if you have one VM, it's even better. But for example, if you have only a laptop, imagine you are confined, you don't have internet, you just need to work on something. You can work on your laptop. You fire a VM, you fire another VM with Cisco Trex. You create two interfaces between the two, and then you run the traffic and do the test. You see the point. And I think this is it. Thank you, Carmen. We have been way beyond 5 p.m. So it was normally 1 hour.
Sorry, Carmen, I have a request. Is that the latest FreeRtr version?
Probably.
Can you run bwmon?
Wait.
bwmon. I think it was exactly the command. bwmon. That's it.
No, it's not the latest one.
Not the latest.
You want to generate the graph?
Well, you can do it independently. I pasted the command on the chat if you want.
Yeah.
I was wondering if that was the newest one. Yeah.
It was no, it's not the latest one, but it's the one that is used for that you can use to do some traffic engineering. So maybe we should ask Alex on how to make this next package available as soon as there is a new one. I'm not sure if we can trigger this, but anyway, we'll see that later. It's another. So Christina, thank you for your presence. Carmen also, thank you for your help and this presentation. And I think any more questions? No? So I guess we can close the session and have a a discussion next week for if you're for another topic. I'm not sure which one it can be. We'll see that. Maybe it will be the sequel with Carmen showing us new tests. Or Jordi, maybe you, wow, there is something we could not do today. It's on Carmen server, we can, of course, instead of activating tracks, we can shut down tracks and we can activate VC-Minar. I think you know the subject very well, Jordi. So maybe we can maybe we can do this next week. So Carmen, you will see that if you want, for example, at some point, not a traffic generator, but you want to have a route IPv4 and IPv6 generator that will blow your CPU, VC-Minar can do that. So we can spin a VC-Minar with Dpdk, and it can send a lot of control traffic alongside a lot of traffic tests. And so we can do that if you want, if you are interested also, Xavier and Christina.
Yes, it would be interesting.
And with that server, I guess if we imply Sava, we can probably also run some VMs running traffic through the Dpdk VC-Minar to the P4.
Yes, so like we can do. You can even do that, clients. But it can be a lot of fun. And Christina, I really suggest you also learn how to install a VC-Minar with Dpdk for one reason. It is that the P4 switch have almost all the features, but the greatest features are sometimes only available using the Dpdk flavor.
Okay, we will give a try. We have some experience with Dpdk in our group for some work, so I think it's very good to give a try of VC-Minar and Dpdk.
That's great. So thanks a lot. And I think that we can close the session. Jordi, I will leave you the last word.
So thank you, everyone, and see you again next week.
Thank you. Bye.
Okay, thank you.
Thank you.
Bye-bye.